In this experiment, we will observe and discuss the reaction of sodium hydroxide with nickel 2 chloride. To begin this process, first we will take two 50 milliliter clean and empty beakers from the containers bench and move them onto the workbench. In one beaker, we will add 1 molar sodium hydroxide solution. For this reaction, we will use 15 milliliters. And we will now label this beaker NaOH. In the next beaker, we will add 1 molar nickel 2 chloride solution. We will be using 6 milliliters of this solution. We will now label this beaker NiCl2. At this point, we will zoom in so that we can see the beakers and the reaction more clearly. The sodium hydroxide is somewhat gray in color, while the nickel 2 chloride is green. Now we will pour the entire contents of the sodium hydroxide beaker into the nickel 2 chloride beaker and observe the reaction. As we can clearly see, a green precipitate forms while a gray solution remains. There was no gas formed.
To explore the possible products of this reaction, we can look at the total ionic and balanced equations. In a typical double displacement reaction, the cations and anions of two different reactants switch places, forming two entirely different products. In the reaction between sodium hydroxide with nickel 2 chloride, sodium cations bond with chloride anions to produce sodium chloride. Meanwhile, nickel cations bond with hydroxide anions to form nickel 2 hydroxide. This is consistent with our observations from the two beakers because the observed products were a green precipitate and a gray solution. As shown through known solubility rules, chloride is soluble and sodium is not an exception. Therefore, sodium chloride is an aqueous solution, and hydroxide is typically insoluble, and nickel is not an exception. Therefore, nickel 2 hydroxide will be solid as a product. Knowing this, it is safe to say that the precipitate formed is nickel 2 hydroxide, and the entire reaction is a double displacement. Having finished this experiment, we may now clear our workspace.